Hello everybody. Today I want to talk about one voodoo magic thing in C++. It's return value optimization. So multiple times I noticed developers who like a lot of developers, C++ developers do not know what is it. So sometimes it's quite important thing performance wise. Anyways, you have to understand things, how C++ works behind. So let me demonstrate what is it. So let's make the directory. So you can have some class, let's say A, and let's make it empty for now. And you can have, let's say this class is, wait a second, something wrong with my keyboard. So let's say this class is quite heavy. It might be like vector, and it can have a lot of elements, and we have function which return value like this, right? So we can have some variable a here, and we can return a here. And I seen like developers was assigning something, and possibly they have some for loop here inside, and they were doing like calling a equal f like this, right? And a lot of times it's kind of makes sense, and it can save, it might be faster, but most likely it's going to be slower if a is heavy class, and like making deep copy of a it will take a lot of time. And here is it, we can see here is it, there is a constructor for a, and we can like do something with a, like if it's vector we can like put some values inside, right, in the loop, and then we return a, it's going to make the copy of local variable a to this variable a. So to avoid this thing, I recommend to do it like this, and this one is going to use return value optimization in C++ compiler. And I tried with my compiler, and actually even with OS0 it does return value optimization. So it's quite easy to demonstrate. So we will have default constructor for a, and we will have copy constructor for a, and inside the copy constructor I'm going to print out copy, and also I want to print the pointer value, oops, I'm sorry, pointer value copy from pointer a to pointer to this. And also I want to make assignment operator. So assignment operator return reference to a equals same thing, and I'm going to print out, but instead writing copy assign from a to this. Let's compile it, and I'm not going to use any optimization, so we will compile it with standard C++ 14 or 17, 14. Okay, return statement, it has to return star this, right? Set but not used, I think it's fine. So now I'm going to run this thing, and you know, let me print out things also before so we would see what is going on. And basically between before and after we don't see anything, and the reason is this I can print out here constructor of this, so we will see when constructor get involved. So before constructor with this address, and after. So if we will do this kind of thing, compiler would not be able to do return value optimization, and we will see how it will call assign operator inside. So we see constructor for this is constructor for this object, and then we see constructor for this object, and then we see assignment from this object to this object in this line. So it's quite like it's invoking two default constructors and assignment operator if we do things like this. With C++11 we got moving constructor, and let's see how it will work, right? So it looks like this, and we will print move. So right now we should see, instead of assign, we should see move. I actually never tried this thing, it's first time then I'm trying, and we see assign, something is not working. Right, because we need to do this thing also. This assign move, let me call assign move. Yeah, here's it, assign move. And the reason why it's calling assign move, because it knows the temporal object inside A is going to be destroyed, so it's using this operator instead of this operator. We can get this operator by like we can create AB and then assign to BA, and let me print here like we are in the middle. So we got this constructor for this A, then we got constructor for function, and then assign move, then it's print out this thing. We got constructor for B, and we got assignment from B to A here. So hopefully it's this demonstration shows you how all these crazy constructors, how it's involved in C++, and how magic works in C++ also. So bottom line, don't do like this, do it like this, and even with old compilers it's going to make good performance code, like, and you would not need to do, you would not force the computer to do some extra things, extra work. And also it looks nice, because before creating this optimization, people kind of forced to do like things like this, right? And you do something with A and just return from this function. And this one is not very convenient way to do things, right? Like you would not be able to do some nice things, like for instance you have like class matrix, and you want to implement operators and like plus multiply, and then have like matrix M1, right, like matrix M2, and like matrix result equals like M1 plus M2, something like this. This looks nice, but without return value optimization it makes like some extra copying, and because before we didn't have return value optimization, we kind of, to make it good performance, we kind of needed to have some functions, and like function sum, right, and then you put the result here, and M1 here, and M2 here, something like this. So which is not look nice and readable. This thing is way more readable. And with moving with R values references, we have more flexibility, and even like this code, not this code, like this sort of code also are going to be performant. Like right now for vectors we can have this thing. We can do with vectors like this thing, but you need to implement these operators to make it work for your user classes, for your classes, for like home, like self-made classes. So this thing I wanted to share with you. Thank you for watching and bye.